अच्छा चलो ये चीज ना कि पेपर 5 के अंदर वो लास्ट टाइम वी वर डूइंग पेपर 5 उसके अंदर भी हमने अभी लैब की जो बेसिक्स है ना वी वर कवरिंग दैट ठीक है। तो अब उसमें ये था कि दिस वाज द लास्ट थिंग दैट वी डिड कि आई टोल्ड यू कि ब्यूरेट हम कर रहे थे ठीक है वी वर डूइंग ब्यूरेट्स। तो ब्यूरेट्स के अंदर वी डिड द बेसिक्स कि वी व्हाट अ ब्यूरेट इज उसके अंदर वी डिड कि जो बेसिक स्टफ है ठीक है। We covered all of that. We learned how to write tables, ठीक है, for a burette. Concordant results, point one CMQ. These values are then averaged to give final answer. ठीक है, वो सारा. How to clean or prepare a burette. ठीक है, उसको साफ कैसा करते हैं. तो वो सारी डिटेल ना minor stuff, which is going to be very important paper 5. अच्छा, then we came to the errors. तो errors in a burette reading. तो error always ठीक है हमने कहा था कि it is the minimum graduation of any device divided by 2. उसकी रीजन ये कि 21.3 जो है ना this 21.3 anything that's 21.3 that's actually half a graduation any value that's half a graduation above and below ठीक है that could be classified as 21.3 because 21.3 is the closest to it. तो इसका मतलब है it's so any value error in any value if somebody says 21.4 इसका मतलब ये नहीं है कि it's exactly 21.4 it means it could be slightly higher than 21.4 or it could be slightly lower than 21.4. So it's the smallest graduation divided by 2. ठीक है, that is your error in any apparatus. ठीक है. तो ये था लेकिन ब्यूरेट में ये कि since the final ब्यूरेट रीडिंग जो है ना फाइनल ब्यूरेट रीडिंग is the difference of two values initial and so it is the difference of two values. और वो two values कौन सी है बल्कि फाइनल ब्यूरेट रीडिंग नहीं the ब्यूरेट रीडिंग is actually बल्कि ब्यूरेट रीडिंग भी नहीं वॉल्यूम यूज्ड ठीक है. So since the volume used is actually the difference, it's the difference of two values. जो कि one of them is the final and the other one is the initial. तो उससे क्या होता है the error adds up. तो burette के अंदर ना so for example if my final burette reading is so my final burette reading is let's say 22.40 cm cube and my initial burette reading is 0.30 cm cube. Both of them have an error of plus minus 0.05. लेकिन जो difference होगा ना that's going to have an error of 0.1. So plus minus 0.10 cm cube. So remember always that the error adds up when you add or subtract two values. ठीक है. So ये clear है? उमर ये clear है? Mava is this clear?
यस सर।
तो ये add up हो जाएगा. अच्छा खैर anyways that's what error is. It's the smallest graduation divided by 2. अच्छा errors को ना if you want to minimize error specifically passage error तो वो भी डिस्कस कर रहे थे. दिस इज नॉट स्पेसिफिक टू ब्यूरेट्स इट्स स्पेसिफिक टू एनी एरर्स. सो हाउ टू मिनिमाइज बल्कि पहले वो कर लेते हैं व्हाट्स द What's the percentage error? तो percentage error क्या होता है? That's the error divided by the value or the total value times 100. ठीक है, that's your percentage error. How do you minimize this? So there are two ways of minimizing this. अच्छा, one way is number one कि error minimize कर लो, ठीक है? To use a more accurate apparatus. So the error would be the smallest graduation divided by 2. So it's going to be, so you're going to have a smaller error anyways. The second method of actually minimizing the error or the percentage error is the total value that you're measuring, make it a larger value. Okay, so the other thing is measure a larger value. So, so it could be a larger mass or a larger volume or a larger temperature. So never deal with smaller quantities. So larger quantities, if you start dealing with larger quantities, your percentage error would automatically be smaller. So it's either going to be you make this smaller, the error smaller, yeah, the value that you're trying to measure, make that smaller. ठीक है, ये भी clear है? Umar clear? Baba, is this clear?
Yes, sir.
So keep this in mind. Instead of in chemistry, what we do in the lab is that we never use smaller quantities. For example, no one is going to measure zero point 0.1 gram because the value is so small. So error to apparatus में ना it's always a constant. ठीक है, a burette will always have the smallest graduation divided by 2. So the error is always there. So if the value is very small, the percentage error is going to be very high. ठीक है, so आप ज़्यादा mass use करते हो, आप ज़्यादा volume measure करते हो. Burette के अंदर भी ना you're not going to try and measure one seam cube. क्योंकि seam cube में 0.05 is the error. So that would lead to a higher percentage error. So you don't do that. अच्छा, next is, ये तो खैर सारा burette का हो गया, ठीक है? The next thing that we do is कि what do we really use the burette for? तो ये यहाँ पे purpose मैंने लिखा होगा burette का. हाँ नहीं, वो हमने लिखा हुआ है. अच्छा, अगले पे आ जाते हैं, which is let's do that quickly. So the next one is a pipette. Plus it's got a safety device which is a pipette filler. अच्छा, इसमें there's not much to talk about. What is a pipette? Uh, first thing, it's got अच्छा, burette के बारे में भी ना वो एक चीज लिखनी थी कि it's very accurate but it's slow. ये टॉप पे, ठीक है, टॉप पे मैंने I've added. It's very accurate but it's very slow. The same goes for a pipette. It is very accurate but slow. So, and normally measures a fixed volume. You can't you can't measure variable volumes. There are pipettes I said there are pipettes which do measure fixed volume, variable volumes as well, but mostly in chemistry, it's this one. अच्छा इसको बना लेते हैं. So it's a thin tube with a pipette filler at the end. Yeah, that's a suction device and it's got graduations. And normally it's going to have just one graduation. So it's either 25 ml or 10 ml or made to order any volume. You can do that. You can, but the problem is, so this is your suction device. That's a pipette filler, or Paki, I guess everyone knows how a pipette works. So I say the error in normal pipettes is normally plus minus because a lot of pipettes are not going to have any graduations. They just measure fixed volume. So it's normally plus minus 0.06 team cube in any reading, but can vary. You get pipette to pipette, the error is variable. You get pipette to pipette, it varies a lot. तो बस और क्या pipette के बारे में बस very accurate, slow, ठीक है. Normally it's used to transfer. So normally it's used to transfer um, a solution from a container to a conical flask. Like a dropper. That's a TISA measurement device. ठीक है, the third one. Let's jump to the third one. That's a measuring cylinder. So what does a measuring cylinder do? It's a measuring cylinder is a device that has ये pipette के ऊपर भी ना you have graduations. Well, a lot of times you don't actually have graduations in a pipette. Some do. So similarly, you've got a measuring cylinder and इसका issue है it's not accurate. So it's not accurate, but it's very fast. So if you want to do things quickly, that's when you're not going to use a pipette, you're not going to use a billet. So when you need to do things quickly, when a lot of times, especially in rate questions, उसमें ना you have to mix things immediately, very, very quickly. So rate questions where you have to oftentimes you have to do things uh very quickly and mix things together. So pipette or a burette will not be helpful in that case. अच्छा और कौन सा measuring cylinder हो गया then you have measurement must be another measurement device. Yeah, I guess measurement device होगी ये सारी. We'll jump to heating, how to heat substances. So we're going to talk about how do we heat substance. The first one, the very first one, number one, that's your Bunsen burner. So what's the issue with the Bunsen burner? It's here or here there's a circular. The Bunsen burner is something that looks like this. It's this Bunsen burner has an air inlet at the bottom. What does that do? It controls combustion, whether things are burning completely or not. So too much air, too little air, and the combustion is not going to happen properly. ठीक है? तो यहाँ पे top पे there's the flame. The normal temperature of a Bunsen burner, you should know that that's normally very close to 1000 degrees centigrade. बल्कि इसको अगर range दे देना, it's around 800 to 1000 degrees centigrade. That's your normal Bunsen burner temperature. Bunsen burners are known for strong heating. Okay, they are always used for strong heating. Uh, जिस तरह you want decomposition to happen, you're going to use a Bunsen burner. You're going to use मतलब you want to get rid of water crystallization. उसमें भी you're going to use a Bunsen burner. Uh, Not suitable for heating flammable substances. Like you're not going to heat ethanol क्योंकि it's obviously a flame. मतलब पेपर को हीट नहीं करोगे इस तरह, ठीक है? तो not suitable. मतलब पेपर में अगर लिख लिया ना ethanol, you're going to heat it with Bunsen burner. You're going to lose marks. So not suitable for heating flammable substances. तो वो नहीं करना. Um, then it also has an uneven heat distribution. But it's got a very pointy flame. So if you have a container, so it's the heat is not going to be distributed evenly. Well, if the flame is pointing on one side, then that side will become hot. So there's uneven, unequal heat distribution when you're heating it with a Bunsen burner. And उसको क्या कर सकते हैं कि how do you distribute it evenly? So you've got things like tripod stands. Tripod stands. उसमें pipe clay triangle होता है, ठीक है? You can use that. Let's make a so और ये छोटी छोटी चीजें they're gonna ask you all of this little stuff. So unlike practicals, यहाँ पे the little stuff counts a lot. So wire gauze, what does it do? Distributes heat. अच्छा इसको क्या कहते हैं? This is your tripod stand. The red one is your pipe clay triangle. What is the purpose of that? It's for So that is for holding stability. ठीक है, just the pipe clear triangle basically provides stability. Uh, so which is why a crucible is needed if you want to strongly heat substances. What does a crucible look like? तो वो भी draw कर लेते हैं. Crucible is basically ये तो खैर crucible नहीं है एक से. तो ठीक है. So this is a crucible with a lid. This one is a ceramic crucible with a lid. Um, used for strong heating. अच्छा, इसी तरह you can use for strong heating. Lid का क्या purpose? The lid prevents spitting. Spitting is when जब आप बहुत strongly heat करते हो, the water vapors they turn into water turns into water vapors. So the substance basically jumps around. ठीक है, it kind of explodes because it's going to hiss. So lid prevents spitting. Uh, बल्कि lid prevents loss of substance due to spitting and hissing. So while you're strongly heating, it's jumping around. So the lid prevents loss of substance due to spitting and hissing. So apart from a crucible, the other suitable apparatus for strong heating is a boiling tube. So that's a boiling tube, and the boiling tube is also used for strong heating. अच्छा, इसमें one way to either temperature के साथ for a Bunsen burner, one way to actually adjust the heat, so you can adjust the flame distance. Well, let's say you're heating a boiling tube, so you can actually bring it further away or put it right on top of the flame to alter heating. ठीक है? अच्छा, that's all about Bunsen burner. और छोटी छोटी बातें वो इम्पोर्टेंट है. अच्छा, इसका ना फ्लेम Bunsen burner का जो फ्लेम कलर है, तो वो ब्लू होना चाहिए. वो मैं एक दफा चेक भी कर लूँ. जेंटल ब्लू. तो वो भी ऐड कर लेते हैं कि द फ्लेम कलर शुड बी the blue flame indicates proper combustion. ठीक है। और कोई मेरे ख्याल से इम्पोर्टेंट बात तो इसके बारे में नहीं है। ये क्लियर? मावा, उमर, इज दिस क्लियर?
Yes, sir.
अच्छा, gentle heating. How do you do gentle heating? अच्छा, number one is thermostatically controlled. Yeah, that's a thermostatically controlled water bath. There are two ways of doing that. What's a thermostatically controlled water bath? Uh, there is one which is electric. The electric one is going to have a water bath. And you can set, there's going to be a panel on top of on it with controls, and you can set up whatever temperature you want to set. Okay, that's one. And you can dip, but a test tube can, what you can do is you can dip your solution or substance that you're trying to heat. तो वो इसके अंदर आप ऐड कर दो। ये क्या हुआ है? ये उठा के ना उसके अंदर so that's one way. The other one is कि your that's also a thermostatically controlled water bath, और उसका जो diagram है ना, that's going to look like this. That's the old-fashioned way. You've got a beaker, and the beaker is again full of water, and the beaker is on a tripod stand. Okay, so there's a tripod stand. ये उसकी legs होगी, and there's a Bunsen burner that's burning, and it's got a flame. ठीक है, तो Bunsen burner है नीचे, and it's got a flame, and the flame is heating the water, and the water reaches a certain temperature. It's not automated, uh, so it's kind of like a manual way, not a thermostatically controlled water bath. There's a thermometer in it, and whatever temperature you want to set, your device operates. I mean, you have to manually control it. So if I want to heat a liquid, so उसमें I would have to dip this substance. So now the good thing with water is that water has a very high heat capacity. So water has high specific heat capacity. So the good thing about that is that it therefore so what it does is it therefore uh, changes temperature slowly. So it's kind of very stable to temperature change. So which is why normally a water bath is good. Plus, the upside is that you can gently heat it. The maximum temperature that can be reached is 100 degrees centigrade. उससे ज़्यादा हो ही नहीं सकता. So the maximum temperature reached, ठीक है, that is 100. I mean, can't be higher than 100 degrees centigrade. ठीक है, that's the maximum for a thermostatically controlled water bath. Safety with a water bath because it's obviously water which is boiling. So safety क्या करना है कि actually it's safety for all heating apparatus. You've got number one, you're going to use tongs. Your hot apparatus always use tongs. Uh, wear gloves so your skin does not directly come into contact with the hot apparatus. So, बाकी especially when heating, this is something that is very, you have to be careful. So toxic, a lot of substances, for example, you're trying to melt something, you're trying to uh, decompose something, so there would be some toxic gases that might be produced. Not always, but you have to watch out. जैसा सल्फेट को heat करो, the chances of sulfur dioxide getting produced. So especially when heating, toxic gases might be produced. So use fume cupboards. मतलब वो glass के पीछे करके ना. In that case, for example, you've got nitrates, so it might produce NO2 gas, which is poisonous. So you're heating sulfates, it might produce sulfur dioxide, which is acidic. You have to watch out for substances that might produce toxic gases when you heat them. ठीक है? अच्छा फिर इसमें ना there's another one which is heat with reflux. अच्छा और इसका ना ये जो thermostatically controlled water bath जो है ना this is for gently heating or for flammable substances as well. Ethanol you're going to heat it this way. So it's good for flammable substances as well. अच्छा heat with reflux वो क्या होता है when you heat with reflux? This is for volatile substances. Again, ethanol is one of them that evaporate very quickly, that have अच्छा उसमें क्या करना है what you're going to do is you're going to have a condenser on top of the apparatus. So there's so in that case you'll have an apparatus and it's air, so water that's going to be water out. There's water. ठीक है, connected है, and that's that's not coffee. Okay, anyways, you've got water in, water out. Or this is filled with water. So any volatile substance, when you're trying to heat it, it will fall back into the container. Yeah, that's heat with reflux. तो वो ताकि evaporate ना कर जाए, so it actually falls back into the container. Heat with reflux. You can remember this is for volatile substances only. इसके ऊपर ना he might ask you भाई why. Uh, I mean some of the vapors might still escape, right? So the opening is kept. I mean it's open at the top. मैंने उससे पूछा ऊपर से open क्यों रखा हुआ है? To prevent pressure from building up. ठीक है, some of it might go up and then it will condense back and fall back into the container, but some of the particles would eventually escape from the top as well. So it is kept open ताकि pressure ना build हो, because you're heating substances and gases, they tend to expand when you are heating them. ठीक है, so gases expand when you are heating them. ठीक है, चलिए, is this clear? Omar, clear है? Mama, is this clear?
जी